The position where the great circle track reaches its highest latitude is called the vertex of that great circle. Every great circle will have two vertices. One will be in the northern hemisphere and the other one will be in the southern hemisphere. At the vertex, the direction of the great circle will always be 090 or 270. That means, in other words, when you are moving on a great circle track and you reach the vertex of that great circle, your course will either be 090 or it will be 270. Either it will be east exactly or it will be west. So that's a important property of this point, the vertex. It is at this particular point closest to the nearest pole and farthest from the equator. So at this particular point, the great circle track is closest to the pole and is at maximum distance away from the equator. Equator is a special great circle which does not have any vertices. So you see all the points on the equator are at 0° latitude. So there is no point having a higher or a lower latitude. So that's why equator does not have any vertices at all. Other than the equator, if you have any great circle on the surface of Earth, it will have two vertices. Okay, we can see a diagram here. Now this is the diagram of the Earth. We can see the North Pole on top. We can see the South Pole at the bottom. And we can see the equator exactly midway between the North and South poles. Now we see a blue color circle here in this diagram. That blue color circle represents a great circle track. So you can see this great circle track crosses the equator at this particular point here. After this, if you are moving in this particular direction, you see the latitude of the ship will keep on increasing and the vessel will reach the highest latitude when it reaches at this particular point. So this point where the great circle track reaches the highest latitude is known as the vertex of this great circle. Now, once the ship crosses this point and moves further, it will start decreasing its latitude. The latitude will start to decrease. And at this point on the opposite side, it will again cross the equator, go into the southern hemisphere. Then the southerly latitude will start to increase. When you reach at this point, again you reach at maximum southerly latitude. So this is the second vertex of this great circle. Now once you cross this vertex, you again move back on the blue color great circle track and reach up to the point where we started off. So we can see this blue color great circle here and both its vertices. Now, as I told you, important thing to remember is that when you are moving on a great circle track and you reach the vertex, your course will always be 090 or 270. Or in other words, the great circle track will always lie in the east-west orientation when you reach at the vertex. Okay, now the second important thing to note here is beta. Let me erase all the ink. Second important thing to note is we can see the two equator crossing points in this diagram. One is this one, which is on our side, and the other point is here, which is on the opposite side. Can you tell me, beta, what will be the d long difference of longitude between these two equator crossing point? Anyone?
Sir, 180 degrees.
Very good, beta. It will be 180 degrees because of symmetry, these points will be reciprocally opposite to each other. Now beta, if you see carefully, the vertex lies exactly midway between the two equator crossing points. So if you have a 180-degree D long between two equator crossing point, now can anyone tell me what will be the D long between equator crossing and the vertex?
Sir, 090.
Very good, beta. So this is another important property of the vertex, that the D long between the equator crossing point and the vertex of the great circle track is always 90 degrees. Similarly, you see this is the other vertex and this is also 90-degree away from the equator crossing points. Okay, now let's come to the third important property of the vertex. The latitude of the vertex, or in other words, you can say the highest latitude which a great circle track attains or reaches. In this case, it is 33 degrees north. You can see it here. They have given the latitude 33° north and 33° south. Now this latitude is always equal to the angle of cut between the plane of the great circle and the plane of the equator. You can see this yellow color highlighted area in the diagram. This yellow color highlighted area shows us the angle of cut between the plane of the great circle and the plane of the equator. And this angle in this case is 33 degrees. Now, whatever is the value of this particular angle will also be the latitude of the vertex. So in our case, the angle was 33 degrees. That is why the latitude of the vertex is also 33 degrees north or south. So that is the third important property of the vertex. Okay, let's proceed further now. This is exactly the same thing which we have discussed in the previous slide. You see, the vertices will be located with a D long of 90 degrees from the positions where the great circle track cuts the equator. You can see here, this is the vertex of the great circle. This is mentioned here. This is the equator crossing point. And you can see the D long between them is 90 degrees. Secondly, the latitude of the vertex is equal to the inclination or angle of cut between the plane of the equator and the plane of the great circle. So that's another thing which we have seen. This we have already discussed.
सर ये एक बार पीछे वाला दोबारा समझा दीजिए.
This one beta?
Yes सर, ये दोनों.
Okay. बेटा ये वही चीजें हैं जो हमने लास्ट डायग्राम में डिस्कस की थी. You see the first para, which is this one. Let me erase the ink and show you again. The first para says vertices will be located with a D long of 90 degree from the position where the great circle cuts the equator. So you see this blue color line is the great circle. This is the great circle and the yellow color line here is the equator. Equator crossing point is this one and the vertex is this one. Okay, up to here is clear, beta?
Yes sir.
Okay, now the D long between these 2 points. You see, this is the longitude of the vertex. And
Yes,
this is the longitude of the equator crossing point. So the D long between these two will always be 90 degrees. That is what the first point says. So is it clear now, beta?
Yes sir.
Okay, the second thing what it says is that the latitude of the vertex, you can see this is the latitude of the vertex, max latitude in the diagram, this one. It will be equal to the inclination or angle of cut between the plane of the equator and the plane of the great circle. You see, this is the plane of the equator. This is the great circle. So the angle at which they are cutting, you can have this angle here also. This is the angle at which they are cutting.
Yes, sir.
Will
Yes, sir.
be same as this particular angle.
Yes, sir.
Okay.
Thank you, sir.
Okay, beta. Now this is okay. We have already discussed. Coming to the second point here. Vertex helps us in quickly calculating the position of any intermediate point on the great circle. What is the importance of this point? If we know the latitude and longitude of this point, we can very quickly calculate any intermediate position on the great circle track. Now a doubt will arise in your mind. What is the need of calculating an intermediate position? Why we require intermediate positions on a great circle track is that when we want to plot a great circle track on a Mercator chart, nowadays we have ACDIS. So on ACDIS, this can be done automatically. You just have to feed in at what intervals you want to have the intermediate position. Now, this method is basically applicable if you don't have access to a ACDIS. You are plotting a great circle track on a Mercator chart. Now, when you are plotting it on a Mercator chart, you cannot plot the great circle track directly. It's a curved line and we don't have any tool with which it can be plotted on the chart. So for plotting this great circle track, what we do is we find intermediate positions on the track. We mark them as waypoints on our Mercator chart and we join them with a single line. OK, so it is actually a series of rhumb line tracks which we follow. You see, the great circle track could be like this. We cannot plot it directly, so we find waypoints. Let's say these are the waypoints which we have. And then we join these waypoints on a Mercator chart with straight lines. So let me show it with a pen. From our starting position, we join the first waypoint, straight line. Then the second waypoint is straight line. The third waypoint again is straight line. Fourth waypoint is straight line. Fifth waypoint is straight line and so on. So we do not follow the curve, but we follow this series of rhumb line courses or tracks. Now, how do we find these intermediate points? Finding these intermediate points is possible only when we know the position of the vertex. So I will tell you now, first, how do we calculate the position of the vertex? And second, from the position of the vertex, how do we obtain a intermediate point on our great circle track? Okay, this is also done. Now, the first thing which we need to keep in mind is, I have told you every great circle has two vertices. So out of these two, which vertex should we be using to calculate intermediate positions? Now, if both our positions, starting position and destination, that is A and B, they lie in the same hemisphere, the vertex to consider also lies in the same hemisphere. Both the positions are in northern hemisphere, north latitudes. So you will take the north vertex, the vertex which is in the northern hemisphere. That is what will be used to calculate intermediate points. If A and B lie in different hemisphere, then the vertex to consider lies in the hemisphere having the higher latitude. Let us say, for example, you see in this diagram, you are going from point A to point B. Both are in different hemispheres. Now, which vertex should we consider? Now, in this diagram, let's assume that point A has higher latitude. So if point A has higher latitude, then the vertex to consider will also be in the same hemisphere where point A is. So in this case, the vertex to consider will also lie in the northern hemisphere. Okay, now the next thing which comes is, how do we find out the position of the vertex? Now, before we find out the position of the vertex, we should know that there are two options or two possibilities regarding the position of the vertex. The vertex can lie inside the triangle PAB, or it can lie outside the triangle PAB also. What do I mean by this is, see in this diagram, you see the vertex is here. Our starting position A is there, B is there. We can see the PAB triangle also, which I have highlighted with red color. So this PAB triangle can be seen highlighted in red, and the vertex is outside this triangle. Okay. Now in some other case, it is possible that if you make the PAB triangle, the vertex may lie inside the triangle, something like this. You could have A here, you could have B here, and the vertex may lie inside the triangle. There are two possibilities. So first possibility is vertex may lie inside. The second possibility is that the vertex may lie outside. Now, before we find out the position of the vertex, we need to know whether it lies inside or it lies outside the triangle. So how do we find out that? Now, beta, when we were calculating our initial and final courses, that time we had calculated angle A and angle B of the PAB triangle. Angle A and angle B ये हमने calculate किए थे to find our initial and final course. If both these angles are acute angles, acute means they are less than 90 degrees. In that case, the vertex lies inside the spherical triangle. If any of the angles, either angle A or angle B, is obtuse, means it is greater than 90 degrees, the vertex to consider lies outside the spherical triangle and it will lie towards the obtuse angle. Let me explain to you. Let's say we had calculated angle A and angle B. Now let's assume angle B comes to be 30 degrees and angle A comes to be 100 degrees. Now we check both these angles, whether they are acute, means less than 90, or they are obtuse, that means greater than 90. We observe that angle A is a obtuse angle. It is greater than 90 degrees. So if this angle is obtuse, that immediately tells us that the vertex will lie outside the triangle, and on which side it will lie, on the side of the obtuse angle. So we extend the great circle track AB towards the obtuse angle, which is A, and we know that the vertex will be outside somewhere. If both these angles A and B are acute, means less than 90. Let me show you another diagram. You can see a PAB triangle here. I have highlighted that triangle in red color. Now in this triangle, we calculated angles A and B. Let's say angle B came to 30 degrees and angle A came to 70 degrees. Now we see both these angles are acute angles. That means they are less than 90. So if both angle A and B are acute, the vertex will lie inside the triangle PAB. So that's why you see we have made the vertex inside the triangle. So beta, I hope up to here everybody is clear. Any doubt coming to your mind up to here?
So what will
Sir,
be the
any
case if the value of A or B is right angle?
Okay, very good. If the value of angle A or angle B comes exactly equal to 90, yes, that can happen. It's a rare case. But if it happens, then you know that point where A or B is, where you have a 90-degree angle, that point is the vertex itself. Okay. If the angle is greater than 90, vertex lies outside. If the angle is less than 90, vertex lies inside. If the angle is equal to 90, the vertex lies exactly on top of that point.
Okay, sir.
Okay, beta. Any more doubts, beta, till
sir,
now?
yes, sir. Sir, both angle, we have to add both angle, and it should not be more than 90 degree. If it is more than 90 degree, then the vertex will be in the outside of this triangle. No, sir.
No, beta, you don't have to add the angles. You have to
Okay,
check the angles as it is. जैसे वो हैं, उन एंगल्स को वैसे ही चेक करना है कि वो 90 से छोटे हैं या 90 से बड़े हैं.
okay, sir.
ओके, दोनों में से कोई भी एंगल अगर 90 से बड़ा हो जाता है तो वर्टेक्स ट्रायंगल के बाहर चला जाएगा. ओके बेटा.
Okay, sir.
ओके, सो लेट्स प्रोसीड फर्दर नाउ. अब हमें बेटा एक बात क्लियर हो गई है. हाउ कैन वी फाइंड आउट वेदर द वर्टेक्स लाइज इनसाइड और आउटसाइड द ट्राइंगल, इसका हमें पता चल गया है. अब लेट्स सी हाउ डू वी कैलकुलेट द पोजीशन ऑफ द वर्टेक्स. नाउ बेटा यू टेल मी, फॉर कैलकुलेटिंग द पोजीशन ऑफ द वर्टेक्स, आप वर्टेक्स इनसाइड द ट्राइंगल लेना चाहते हो या आउटसाइड? I will make a triangle like that and show you how do we calculate the position of the vertex. Let's make a PAB triangle. We want to take the vertex outside. So let's assume this is our starting position and we have a obtuse angle. So let's say this is our second position and let's say this is the great circle track which we are moving on. Something like this. This is our position A. This is the position B. This is the pole P. Now when we check out these angles, we see angle A is acute, less than 90, and we check out this angle B. Angle B is greater than 90. So if this angle is greater than 90, we immediately come to know that the vertex will be outside the triangle and it will be towards this angle B. So let's make a vertex. We mark it with V and we join the PV side also. Okay. Now beta, tell me one thing. When you reach at the vertex, what is the direction in which the great circle track lies?
Sir, east-west direction.
Very good. So this tells me that the great circle track is running in the east-west direction when you reach at the vertex. Now beta, anyone can tell me what is this Papa Victor side? Papa Victor side. What was Papa Alpha side, beta? Do you remember?
So longitude.
Very good. It was the longitude of A. And what was Papa Bravo?
So longitude of B.
Very good. That was longitude of B. So what will be Papa Victor?
So longitude of vertex.
Very good. So it is the longitude of the vertex. If you extend it, it will go and meet the South Pole. Now, when you say that this is a longitude or meridian, what is the direction in which the meridians run?
North-south direction.
North south.
Very good. So you see the meridian is running in the north-south direction. The great circle track is running in the east-west direction. So can you tell me what will be the angle between these two?
So 0,
90.
Very good. It will be a 90-degree angle. Between east-west and north-south, this angle will be a 90-degree angle. So this tells us that angle V or vector of this triangle is going to be a right angle. Now, beta, you remember when we did a normal great circle problem? In that great circle problem, we knew that this papa alpha side is the colat of position A. So latitude of A was given to us and we did 90 minus latitude that gave us side papa alpha. So basically this side papa alpha is known to us. Secondly, you see this angle A here. This angle A was calculated to find out our initial course. So we found our initial course using this angle A. So both these things are known to us. Now what we will do is we will enter into triangle Papa Alpha Victor PAV triangle. Now this PAV triangle, Papa Alpha Victor triangle, is a special spherical triangle. All three sides are great circles. And what is the speciality? Angle Victor is a
Right.
90-degree angle, is a right angle. So we have a special spherical triangle and we have two things which are known to us. So can you tell me beta which rule will apply here?
Sir, Napier's rule.
Very good, Napier's rule. So we can apply the Napier's rule here. Let me make the Napier's diagram. We divide it into 5 parts. In the bottom 3 parts, you write 90 minus, 90 minus, and 90 minus. Then you can fill up the parts. Vector angle is 90 degrees, so we place it on top.
सर
You
हम
want to
ट्रायंगल PBV यूज नहीं कर सकते?
बिल्कुल कर सकते हैं बेटा, उसमें थोड़ा सा डिफरेंस आएगा, वो भी मैं बताता हूँ आपको. लेट्स
वो तो
फिनिश
सर
दिस
हम
एंड आई टेल यू.
एंगल कैलकुलेट कर लेंगे 180 माइनस करके.
Very
एंगल
good beta, that's right. If you do that, you can use Papa Bravo Victor also.
ठीक है सर.
Okay. Okay. So let's apply the Napier's rule now. Victor angle we have marked. You want to go clockwise or anti-clockwise beta?
Clockwise, sir.
Okay, let's go clockwise. So we move like this. After Victor, the side is AV, alpha Victor. So I write it here. Then we get angle A. Then we get side Papa alpha. Then we get angle P. And then we get Papa Victor. And our Napier diagram is filled up. Now let's see what all things are known to us. We know Papa alpha side. So Papa alpha is known to us. This part is known. We know angle A also. So this part is also known. These two parts are known to us. Now what we do is we enter into the Napier formula and we find out. What do we find out? The first part which I am going to find out is Papa Victor. This is the part. So beta, can you tell me which formula will apply here? Tangent adjacent or cos opposite?
Cos opposite, sir.
Very good.
Cos
So cos
opposite.
opposite लगेगा formula और middle part कौन सा बनेगा?
PV.
Very good. PV will be the middle part and other two will become opposite parts. So do you want me to apply the formula or you can do it? बेटा लगा लोगे formula or shall I apply it here?
नहीं लगा लेंगे सर.
Okay, all right, then I'm leaving it. So we take the middle part as PV, opposite parts 90 minus A and 90 minus PA. We apply the Napier's rule. Once you do that, तो आपके पास पापा वेक्टर साइड की वैल्यू आ जाएगी. Now दिमाग लगा के बताओ बेटा कि ये जो पापा वेक्टर साइड हमारे पास आई है, ये क्या चीज है? What is this?
Sir, colat of the vertex.
Very good beta. This is the colat of vertex. So if this is the colat of vertex, 90 minus this will immediately give us the latitude of the vertex. So latitude is known to us. Okay. Now let's move on to the second part. We want to find the longitude also. So for the longitude, we again enter into the Napier's rule. Now this time we have these two known parts. Two known parts are already marked with the arrow. Now what I find out this time is I will find out angle P, this angle. So angle P को find out करने के लिए this is the part which I need to find out. So beta now tell me which will be the middle part.
90 minus
90
P.
minus PA.
Very good. 90 minus PA will be the middle part. Other two will become adjacent and tangent formula will get applied here. So once you apply that, it will give you angle P. So हमारे पास ये angle P आ जाएगा as we apply the Napier's rule. Now see carefully in the diagram and tell me what is this angle P, beta?
So
So
D long
D-
between A and vertex.
Very good. It is the D long difference of longitude between A and V, alpha and Victor. So once you know this D long, longitude of A is given to you in the question itself. So when you apply this D long to the longitude of A, तो हमें क्या मिलेगा? हमें मिल जाएगा longitude of the vertex. So this is how we obtain the position of the vertex. It's a simple application of the Napier's rule. So you apply it 2 times and you have the position of the vertex known to you. So beta, any doubt coming to your mind in calculation of the vertex, please share. So clear hai beta, understood by all?
Excuse me sir.
हाँ बोलो बेटा.
सर अगर वर्टेक्स हमारा अंदर होता ट्रायंगल के तो क्या डिफरेंस आता?
Okay, कोई डिफरेंस नहीं आता बेटा. The question would be exactly the same.
ओके.
सर एक क्वेश्चन है और जो टेक्स्ट बुक में दिया है और लैटिट्यूड लॉन्जिट्यूड दिया हुआ है फ्रॉम टू and then it is asking find the latitude.
Beta, can you speak a little louder, please?
Yes sir, are you able to hear me now?
Certainly, loud and clear.
Okay sir, in the question it is asking find the latitude in which the great circle track in the question crosses the meridian of 180 degrees.
Okay beta, just wait 5 minutes and you will be able to do it.
Okay sir, thank you.
That is the next thing which we are going to do now. So up to vertex, I believe everybody is clear now. So we proceed ahead. I told you the vertex helps us in quickly calculating any intermediate point on the great circle track. So let's now try to calculate a intermediate point. Exactly like he has said. So beta, can you please repeat your question now? Let's do that question.
Yes sir, I repeat it for you. It is given that latitude, the initial latitude is 30 degree 20 minutes south and longitude is 142 degree 45 minute west. Going to the vessel, latitude 50 degree 40 minutes south and longitude 170 degree 30 minute east. It is asking find the latitude in which the great circle track crosses the meridian of 180 degree.
Okay, all right, beta. Let me mark it here. We will actually find out a position in this triangle itself. So they are asking us to find the great circle track crossing a particular meridian. Okay. Now let's assume that the meridian of A is 30 degrees east. And let's assume that the meridian of B is 70 degree east. Now they ask us in the question, Find out the point where the great circle track crosses the meridian of 50 degrees east. So let's first draw 50-degree east meridian somewhere. 50-degree east meridian is going to be somewhere here. Let me erase this arrow so that it is clear to you. Okay, so let's assume that this is the 50-degree east meridian. And we now basically want to find out this point. So whatever point we want to find out, we name that as X. X is always what we are finding. So we have this X with us here, and this is the position which we want to find. So how do we do that? Now for this beta, we now move into triangle PVX. Let me erase the lat long and the Napier's. We will have to apply it again. Okay, beta. Now look at triangle Papa Victor X-ray PVX. Now, beta, in this triangle, this is a special spherical triangle because you see all three sides are great circles, and we have a speciality. Angle V, angle Victor is 90 degrees. So we can apply the Napier's rule here. Now, when we apply the Napier's rule, we need to know two things other than the right angle. So what are the two things which we know in this diagram? Papa X-ray Victor, या Papa Victor X-ray. So can anyone tell me, beta? केयरफुली देख के बताओ कि इस ट्राइंगल में कोई दो चीजें हैं जो हमें पता है. नो वन बेटा, किसी का माइंड में नहीं आ रहा? ओके, हमने अभी वर्टेक्स की पोजीशन को फाइंड आउट किया था. सो द लैटिट्यूड एंड लॉन्जिट्यूड ऑफ द वर्टेक्स इज नोन टू अस. So we have this Papa Victor side known now, beta. After vertex position is found, we know what is this Papa Victor side. It is the colat of the vertex. Right? So this is the first
sir,
thing.
we know the side XV as we have the D long.
Okay. अब बेटा you are partially right. हमारे पास x का मेरिडियन है which is 50 डिग्री ईस्ट, और हमारे पास वर्टेक्स का मेरिडियन भी है. लेट अस से वर्टेक्स मेरिडियन इज 100 डिग्रीज. हमने इसे कैलकुलेट किया है इन आवर प्रीवियस स्टेप. सो साइड XV is not the D long beta. XV side is never the D long. The D long is the angle at the pole contained between the meridian of two places. So the D long is basically this angle P. This is the D long between vertex and X-ray beta. So you know you know point X meridian is 50 degrees east. You know the meridian of the vertex is 100 degree east. So that tells you that this angle P will be equal to the D long between both of them. And you can easily find out what is this angle P. So this is the second thing which is known to us. So Papa Victor X-ray triangle, special spherical triangle, two things are known to us. One is side Papa Victor, which is the colat of the vertex. We have the latitude of vertex with us. The second thing, angle P, which is the D long between Victor and X-ray. D long, the definition is angle at the pole contained between the meridians of two places. So this is also known to us. With these two, we enter into the Napier rule again, and we can find out. Okay. So if you want me to apply the Napier here, I'll apply it. So you have Victor, If you go clockwise, the first part here will be X-ray vector. Then you will have angle X. Then you will have Papa X-ray. Then you will have angle P. And then you will have side PV. What is known to us is side PV and angle P. Now, can you tell me what thing we need to find out here to get our answer? Anyone? लगाओ दिमाग बेटा.
90 minus x.
Very
Sir,
good बेटा.
PX.
90 minus x, one option. Second is px. Okay, second option. So कौन बनेगा navigator? Option A, option B.
So peaks.
Right. Px is what we are going to find out. So how will Px help us? So Px is what we are finding out with the Napier's rule. We can easily apply the Napier rule now. 90 minus P will become the middle part and other two will become the adjacent part. So you find out Px and the Px side, which is this side here, is basically the colat of position X. So once you have this colat with you, 90 minus colat will give you the latitude of this position. So latitude of X is known to you. The longitude was already known. They had already told us that it lies on 50° east meridian. So we have this position X-ray known to us. So this is the way how we use the vertex to find out any intermediate positions on the great circle track. So beta, whatever doubts are coming into your mind, you can please share with me. Okay, so the method is clear, beta? Clear to everyone?
Yes, sir.